Okay, so we are in between slides. We're going to finish up our Linux command line little terminal command stuff, and then we will start some new slides, some very exciting slides about inheritance. So, all right, let's talk about how to make what's called a shell script first. So, you may have noticed that sometimes when you do something, like I could have, sometimes when you do something repetitively on the terminal, it would be nice if you could automate it. Like, a good example for me was there was a bunch of commands I just made to like make a new folder for today's lecture, get into the right spot, split my screen. Like I could automate that, but I'm lazy. Here's how you could automate something like that. You make what's called a shell script, which is a program that just has a bunch of terminal commands in it. Essentially, a makefile is a shell script in that sense. You could use a makefile for this purpose, just like run a bunch of commands in order. So you know how to do it already technically, but a shell script is kind of even simpler. It's just a program that has a bunch of terminal commands line by line. If you think about it, like it's like C++, but no semicolons or anything. So let's make a shell script that like does a bunch of things at once. It makes a file using echo and like redirection. It'll print out the file and then like copy it to somewhere else. Okay. So that's my job. We're gonna make a program, a shell script that runs all those terminal commands that do all those things all at once. It's like one command that does them all. It's essentially a function, in a sense, on the terminal. Maybe we can think of it that way. And so the standard extension is either nothing or .sh. So yeah, alternatively, some people don't use any extensions. Just like our normal executable files, we don't say like .exe in Linux. We just say like /main or whatever. Yeah, so that's the thing. Let me show you how to do that. So here, new program. I want to make it, and I'll call it sample script.sh. And yeah, what we can do is we can write a bunch of lines in this. We just write a bunch of terminal commands. Also, just like for makefiles, you could use comments as well. Those don't count as commands, but they're there for you. The number sign is the comment. So just like Python or the makefile language, a number sign is a comment. So like this is a comment in the shell scripting language. That's great. And so every line in this file is a terminal command. So does that imply that a number sign command is a thing? It does. It just does nothing because it executes by doing nothing at all. So that's cute. So yeah, let's do what we wanted. So a line without a number sign. There we go. Let's make a file by echoing out to the terminal. Hi, Mom. By the way, I think no, this is fine. Hi, Mom, and then I'll redirect it immediately to a file. So don't print it out. If you didn't say redirection, it would print out as you ran the thing. That's kind of cool. We can say cat to do that though. Cat file.txt, and then let's copy that new file that just got made after it got printed to us after we made it, right? Let's copy it to file copy.txt just for fun. So 3 things all at once. That's our program. And so to run it, you say the name of a terminal emulator. Sorry, not a terminal emulator, but a shell. You say the name of your shell that you want to run it with, and then the name of the file. So bash is the default shell on, like it's the thing that interprets your terminal commands when you log in on the server, unless you change that. I actually use a different one, but that is beside the point. So I say bash, name of the script, sample script.sh, and oh, before I do that, nothing else in this folder. So bash, sample script.sh, hit enter. We got hi mom printed, which is what cat did, right? Concatenates a file. And then also I have 2 files that are brand new. Did all the things all at once. Isn't that nice? And so you better believe that the contents of those 2 files is hi mom both times. Yes. Wonderful. So yeah, I think that's what I want to say. Any questions about that? Just a file that you can put a bunch of terminal commands in. You technically could have done this with a makefile, but it's a little bit simpler than that, I guess, here. So there's that. It would be very nice to run it like any other program that we have. Like, why I should be able to say /prog.sh. That's a thing. That would be great. And you can do that. That is a thing that you can do. And let me tell you the secrets. So if you would like your file to be able to be executed by the current user who owns the file, the one who just made it, you say this command. It's called chmod. It change the mode bits of the file. So It's a little weird. You can look up the man page, but it's like for the user who owns the file, add the executable privilege to that file, and then here's the name of the file I want to mess with. You say that, and just because I am sharing files between windows by default, it's doing that. It's like green. It's green already. If you do ls-l, it shows you the bits. It's like I have every permission everywhere for all of these things, so it would work for me right now. But by default, files. Let me like log into the server really quick. Or no, let me just go to my home folder here. Boop. I got a bunch of things. Perfect. I've got a C++ file and an executable file that I made from that C++ file. If I do ls-l, this is like the Linux part. Notice how on the C++ file, there's no X right here. It doesn't mean I cannot run this C++ file. It's not something that's runnable. I have to compile it, right? And then here's the compiled thing is like X. It is runnable. It's executable. So G++ does that for us by default because we want to run the things that we've compiled. But if you make a shell script, it just thinks that it's a text file by default. It's like you just made, it's as if you made a CPP file or something in Vim. That's what Vim does. That's the default. It's read-write privileges for us. No execute privileges for us. The rest are like for other people, like for the group owns the file, for like everybody else on the system. So those are other things that you could look into. chmod does it all, changes those things. And yeah, so if I was not in Windows, this would not be like this, and so I'd have to say something like chmod u plus x. Like imagine that this x right here was not there, and then sample script.sh, hit enter, it would have added the x, and then you're able to say // on the name of your sample script, and it would run. By default, but also sometimes it's okay. That's enough. And like that one works for my particular shell that I'm running. Like it'll probably work on yours too. But sometimes you want to be very pedantic. You tell the program, your shell script at the very top of it, you say which shell it needs to run in, because there's others. The one that I use is called Z shell, ZSH for short. The one that you guys have on the server is called bash. There's like a more simpler one that they all came from called sh. There's a bunch of different ones, and so the way that it executes commands are slightly different. And so if you want to be very specific and be like, I want this code to run in this kind of shell, you use a little comment at the top called a shebang. It's a cute little name. What you do is at the very top as a comment, you say an exclamation point, $! Point. It's like hash, and then some people say that the exclamation point, they say a bang, so that's kind of why it's called that, hash bang. Gets shortened to shebang, I guess. And then you say the location of the terminal of the shell you'd like to run this script. This is all beside the point. I'm never going to test you on this, but you may see this one day. So like, I'd like this to run in bash, which lives in the bin folder in the root directory. And so now for sure it's going to run that thing in the bash shell, and so it has all the quirks that bash has. So it all still works though. Okay. So yeah, I think that's all that I wanted to say. Any questions about that? So just like a shell script is it's a program that's just, it consists of a bunch of terminal commands. It's useful if you want to automate stuff. You can also get input. There's ways to do all that. It's like, it does not have to be in C++. You can do just a bunch of shell commands. It's all possible. Very interesting and weird though. It's a little bit different than what you know because it came before. So yeah. Fun stuff there. If we're good with that, let me show you some things that some of them you already noticed, but let me show you some others as well. So we know, hopefully by now, that if you press the up arrow, you get all the commands you've just typed, right? Press down, you go back to, I can go in order like that, but there's even more, all right? So if you're in a pinch, you say exclamation point, that will turn into the last thing you just did. So last thing I did was that, $, or sorry, not $, exclamation point twice, just reruns that thing again. It finds it for me. I don't have to retype it. That's kind of nice, right? Let's say it's not the last thing, but you know that you want to run the last command that started with blah. Then you'd say exclamation point blah. That would be great. That would be nice. So a good example of that would be, let me would be like last time's lecture 24. Like, let's say I changed example.cpp, but I just ran it. So it's not the last command to recompile it. But if I say exclamation point G, oh gosh, no, it'll find something else. and it'll find the G++ command that you used to just compile the thing. Does that make sense? That's the most recent thing you did that started with a G. Isn't that cool? If you want to be very specific, like exclamation point G++. Bam! It found the one. Isn't that nice? It saves you time. So I've never shown that to you, but now you know. There's more where this came from. So look into this kind of stuff if you're interested. You see how it could save you time, right? Yeah, and so these ones are fun. These I use a lot. You may have noticed me use them, but not know how I did it. If you use commands, if you're in the middle of typing a terminal command and like you want to change a piece of it, here's how you like move around really quickly. You can do stuff with Control and Alt, like Control A, E, F, B, D, and then Alt, F, B, D. There are ways to do it. You can also change your shell into Vim mode, where as you're typing commands, you have to hit insert and stuff. You can use the Vim stuff, but this is the Emacs stuff by default. So that's interesting in itself. So let's say you've got your, I don't know, you've got that one, your chmod command. Oh gosh, something's wrong. There we go. It's at the top now. So you got your chmod command, and like, oh no, I spelled something wrong, or I want to GDB this program or something. Like I have /example, and no, I want to run it in GDB actually. So Control A goes to the beginning of your command, just like immediately. It moves the cursor to the beginning. Control A goes to the beginning. Control E goes back to the end. A, E, A. Control A, Control E, Control A, Control E, and then you can start typing. It's amazing. There's that one. These ones are not as useful, because you could just use the arrows. You already have those. But if you already got your hand on the control, it's like Control A to go back. And then you can say Control F to go forward, one key, and Control B to go back. It's just like left and right. Left and right. That's nice. And then Control D is useful. It's like it deletes the current character your thing is on. It's like sometimes I go to the start and like I delete a few things. Something with Control D. You don't have to like change where your hand is if you're moving around. So that's kind of useful. That's nice stuff. So that's character-based control, and then Alt you think of as like word-based. So Alt goes and passes over spaces. So like Alt F goes forward a word, Alt B goes backward a word. So echo, hi mom. If I do Alt B, that's moving backwards a word all at once. Alt F is moving forwards a word all at once. Isn't that nice? So I can immediately go back and like, that's how I changed, like, oh, it was G++, example. Oh no, Alt B, Alt B, Alt B, get back. Alt D deletes a word. And like, oh no, it's a different file now. See how fast that is? I've done that this semester. I like those ones. So Alt F, Alt B, Alt D, those are useful. Also Control A and E I like a lot. These ones I don't use as much, but you have them. All right, so there's those, useful to know. And then, let's say you're working on a couple files, you want to compile them in G++. It wasn't the last thing that you did that started with G++. It wasn't that one, but it was like the one before it that you want to get at. You don't want to remember it. So Control R starts a reverse search through all the commands you've just done recently. So Control R, you start typing G++, it'll find, see how it's underlining the things that I've typed so far. That's the most recent G++. If I type Control R again, it'll find the previous one with G++ in it. If I keep typing Control R, eventually I'll get to the program that I wanted to get to that had G++ in the command. And it doesn't have to be at the start. Like if I want to find that again, like merge sort, Control R, just start typing merge. Like here all the time, so I said merge sort. And eventually I'll get to what I wanted with it. Isn't that neat? Question?
Mac, what would you use instead of
For Mac, you would use option. I think the default is option. It does depend on the terminal program, so I'd have to check that because I don't use the default terminal on Mac. Well, we can look together. In the preferences, though, you can change which one does what, but I think it should be defaulted to option if I remember correctly. I've changed it all around on my Mac. I changed option to be control on the terminal and command to be alt on the terminal because they're right next to each other. It's easier for me. So you can get weird like that, but that's, yeah, useful stuff. Other questions? Yeah, this is just about getting faster and doing things that you want to do more efficiently. You don't have to know any of this. Of course, you've been able to get by just fine without this, but it's useful. And there's plenty more stuff that I don't do, like I should be doing, like the exclamation point stuff. So there's that. Yeah, here's some more that sometimes I don't use, but still kind of useful. So you know that when you say CD, it changes your directory to somewhere. Like I can say here I am in my lecture 25 folder. If I say cd to my home folder right now and I go look around and do stuff, /a, whatever that was, I want to go right back. I don't have to remember where I was. What is happening is secretly it's keeping track of a stack of directories you've been in so far. Like if you move over quickly. And you can add to the stack, you can push the stack. Push D pushes a directory. Pop D pops a directory and moves you back to where you used to be. And so if I were to type pop D right now, it's kind of cool, pop D, it would move me back to the lecture 25 folder. Isn't that kind of nice? It would pop the stack because like I pushed when I CD'd essentially. That's kind of neat. So let me go back to my home folder. Let's move around. If you want to see the whole stack, you say dirs, or better is dirs-v. So like here's the stack of directories. I'm in my home folder right now. I just came from the lecture 25 folder, so if I pop the stack, this one would be my current directory. Does that make sense? And you can go around a bunch of places, be like cd, just give me the root directory now. I've been a million places now. If I pop the stack now, I go back to my home directory. I pop it twice. I can go back to the lecture 25 folder. If you want to like keep everything on the stack, like you want to remember all these places so you don't have to retype them again, you can keep the stack as it is, but you can shuffle it around by saying push D plus N. And that'll shuffle the stack around, which is something you don't normally do, but it's useful for this. Shuffle it around by N, whatever that number is, making the stack directory N your new current one. So if I want to go back to lecture 25, that's directory number 2 on my stack, 012. Shuffle it then by 2 to move me back to here, but also keep the home folder and the root directory on the stack so I can get to them later. So push D plus 2 would get me back. Oh goodness, I did it backwards. No, that should have worked. Where am I? Dirs-v. Oh, maybe this only works on bash, by the way, sorry. Push D, that should have done something. Plus 2. Maybe it's plus 1. Okay, plus 1 does something. Plus 0. Weird. Plus 3. No. So for some reason it's unhappy, and I don't know why. But at least 1 will get me there. Okay, I guess I can go by 1s on my thing, but it wasn't working with the other way. If I was in bash, it probably would have worked just fine. That used to work. Weird. But now you see that I've got it here, and I got the other things underneath it, kind of. And so that's just complicated, weird stuff. But it keeps them all there so that you can move around between a bunch of different places easily, I guess. That's how you can think about it. So yeah, those are those. Let's see. Yeah, I think that's all I wanted to say. You can arbitrarily you can do that with your own, like push D/bin or something, and so you can add to your stack, and it prints it out for you. Like it's all there. If I say pop D, gets me back to where I used to be, the thing underneath it on the stack. Nice. And so I don't think I really ever use this at all, but it's there. It's useful. It's secretly keeping track of a stack, which we know about in CSCI 41. So that was useful to know. Yeah, I think that's what I wanted to say. Any questions about those? Just think.
Do you push D minus?
Yeah, let's see. Probably. Push D minus, well, let's look at our dirs. Push D minus 2. Oh, maybe it was supposed to be minus for this one. That moved me down to tilde. Oops, yeah, push D minus 2 minus 1. Yeah, so maybe minus was the better way to do it for the Z shell, which is the one that I'm using right now. So maybe the plus was bash, just specific. Yeah, because it's built into the shell itself. There's nothing about it in the man page. It was part of your shell. So bash has its own. This is the bash shell. Yours looks more like this. So if I move around like cd/ cd tilde dirs-v, oh goodness, cd Windows desktop. Yeah, it works a little bit differently because that one didn't actually add anything to my stack. So push D tilde, push D root directory. So there, yeah, it works completely differently on different shells. If I were to say push D plus 2, yeah, that way works now. So the one that you know is probably where I should have been this whole time. That one's going to work. All right. Yeah, no, that was awesome. But minus 2 apparently is what mine wanted. So that's great to know. Thank you. Nice. So yeah, I'll have to put an aside there. Other questions, other thoughts. This is just useful stuff. One day you'll want it. All right, a very useful one that you may want one day is if you have a URL to something important, like an image or a zip file or some piece of code, you just say wget, short for webgit, and you just give the URL, you hit enter, it will download that file into your current directory on the terminal. That's very useful. So like if we were on GitHub and we had something we cared about, I don't know, you could honestly just download a web page, so wget google.com. Ta-da! It downloaded the index.html file from Google. That was the default thing that it gave to us. And here is the Google website. Whee! Disgustingly shortened. It's got like 14 lines, and you better believe those lines are very, very long. 18,000 characters on that line. So that's disgusting. Remove. But yeah, that's what you can do. That's useful for like getting a zip file, then you can unzip it where you were. That's a thing. And then yeah, the last one that I want to show you is useful. Definitely something you'll want to use. It's called a wildcard. It's the star character. So if you use star in a terminal command, it will just fill in with anything that matches. File names usually is what you care about. But you think of the star like a black hole, and it's going to suck up anything that matches after that point. So and we'll try to fill the hole, essentially. So if you say file star on the terminal, it's going to match this with anything that starts with file. File, and then fill in the blank. Fill in whatever you want. Could be nothing. Could be file by itself, and then file A, file B, file C. Like this can fill in with nothingness or somethingness. Okay? That's the thing. Usually use it like this. Like, give me every text file in the current directory. Star.txt is how you get that. Give me every CPP file in the current directory. Star.cpp. Star by itself is every file in the current directory. And so usually you could do something like this if you're lazy with G++. You don't want to like do compilation ahead of time. You say G++ star.cpp-o something. Compile every CPP file in this folder into something. So that's useful. So for example, I've got 2 text files in this folder. I can say print them both out. Cat star.txt. Boop. And so it prints them both out. Cat file star as well, because they both start with file, right? Cat those both out. It will become them both. On my shell, if I press tab here, it will autocomplete and show me what it was going to do. Like it turns into those. Cat file star again. Tab turns into those. Does that make sense? That's useful. Yeah, I think that's what I want to say. Any questions about any of those terminal commands or processes on the terminal? I guess some of these aren't. That's technically not a command, just a feature. So I like that. That's useful. And yeah, with that, I think you know how to get more help. You just be like Linux terminal command tutorial and the like shell script tutorial. You can get more information there, but now you have a good starting point. Yeah. So I think that brings us to the end of this set of slides on just a bunch of weird topics all at once. Are you ready for a new topic? All right. I should have kept that open so I could save the things for later, but that's all right. Next, I would like to teach you a wonderful topic called inheritance. It is a very powerful topic. It's something that is we're going to need for our very last lab in this class. It's very exciting. It's something that we've been taking advantage of secretly for a while, especially with files and stuff. Like we swept it under the rug in CSCI 40. Let's make it explicit now. All right. Let us begin. Let me set the scene for us. We need inheritance, and here's why. So this is like a very powerful feature of object-oriented programming that you may not know yet. Okay, so go back to your CSCI 40 textbook, at least those of you who took my version of the class. There's an inheritance chapter that I never forced you to read. Now's a good time to read it. So, okay, let us set the scene. So let's say we want a cat class, because we want to represent cats inside of our programs as a human might want to one day, as normal humans do. So here is a cat class where it's got like a constructor, name, age, favorite food, and then my cat's name is Alonzo. It's short for Alonzo Church, so that can be his full name. Like here's me instantiating an object of the cat type. He is now 5, so that's his age now. What a good boy. Now, what do we want cats to do is the question. Like, they should be able to talk, right? Cats say meow and we ask them to talk. We should have getters and setters for all of the member variables, right? Those are the things that got set in the constructor. Name, age, favorite food. So this is all the data associated with a cat. I love that bug in PowerPoint. It was selected, but it was the wrong color. So that's all the data that a cat class should have. And then these are all the getters and setters for that data, which you should want to have as a good object-oriented programmer. Getters and setters. Boop, just like that. Cat class. Make enough sense, right? Dog class. I'm going somewhere with this. Let's say we want a dog class too. Victor E. Bulldog, the mascot of Fresno State. I have no clue how old he is. Let's pretend he is 3. Because there's different reincarnations of this dog. What do we want for a dog? Every dog should have a name, an age, and a college they're associated with, right? We need that. That's important. Every dog goes to college, or at least as a mascot for one, perhaps. And so here are the getters and setters for that data. Every dog should have name, age, and college. Dun, dun, dun. So here, getters and setters for the name, age, and college. And then when you ask a dog to talk, maybe every dog is a Fresno State mascot and they'll say, go dogs go. Or you could say woof, something like that, right? So if I flip quickly between the cat class and the dog class, you will hopefully notice something that I'm getting you to notice, right? There's a pattern here. Do we see the issue? Do we see a problem? Can we explain it in words? Do we see something that's happening? There's a lot of similar stuff. There's a lot of even exactly the same stuff for name and age, right? Exactly the same. There's also something called talk for each of them, right? There's a lot of duplication, all right? There's a lot of duplication. Like if you think about it, here's what a cat has, all the data, the properties of a cat. We've got name, age, favorite food. For a dog, we have name and age still. The college is now different. It's not favorite food, it's college now. And then methods, like you have getters and setters. Those are your behaviors. But there's also something called talk for each of them. But they just say different things, right? It's like a different implementation. Does that make sense? So the question is, like, we can stay together and think about this. Like, what do you want here? You don't want to have to copy and paste, right? We agree that that's a bad thing. Yeah, that's extra things that could go wrong if you accidentally mispasted or something, right? You changed one thing one place and now it's not correct in the other place. If you wanted to update the way that you do get name or something or set name, like maybe you wanted to make sure that there was a capital letter or something as the first thing. Like you have to change it a lot of places now, and that's not all right. What would we like? Do we have any like wishes? Make it templated. That could work. You can do really weird stuff with C++'s templates. I agree. That's a potential thing where it's like the class is templated by like, is it favorite food or college? Like what's the other member variable? You can do weird stuff like that. That could work. But I think just like the goal should be, right? I would like to not have to duplicate stuff. I would like to do the minimum amount of work between cat and dog to show what's different and keep everything that they have the same together somewhere. Does that make sense? Like, do you see how that would be a good goal to have? Is that logical enough? Because that's what everybody's essentially agreed on. Like, we would like to reuse anything that we could possibly reuse here. All the things they have in common, let's keep them together somewhere so that we don't have to keep on redoing things, keep on copying and pasting things. And here's enter the idea of inheritance, all right? So cats and dogs, we've noticed, they share a bunch of stuff. Cats and dogs are similar, right? Because they're both animals, aren't they? They're both animals, and animals have certain properties and features, right? Even in code. So I think the idea should be, let's make a third class called animal, where we put all the pieces that cat and dog have in common, that any animal should have, right? They got names and ages, squares and triangles, yeah? Put all the shared pieces up there. And this is called an inheritance diagram, shared pieces. All right, and then each of these arrows represents an inherits from relationship. Inherits from. Cat inherits from animal. Dog also inherits from animal. You can also read this relationship of inheritance as an is a relationship. That's a thing that some people say that's equivalent to inherits from. That should scream inheritance if you ever notice that something is something else. Because a dog is an animal, right? It should have I guess is an if it starts with an A, but whatever. A dog is an animal, and that means it should take any animal features just for that generic animals have, and then update down here with extra things that are specific to cats and specific to dogs. Does that kind of make sense? So put all the shared stuff somewhere else into a third place, have cat and dog inherit the shared stuff. That's the technical term. We'll show you how that really works. And we'll go from there, right? So like the key was we noticed they share a lot of information because there is a relationship going on. They are both animals. It's very philosophical today. They are both animals, and so there should be an animal class that they're taking stuff from, and that's where we put all the commonalities, right? You can imagine that this could be even deeper. Like animals are, I don't know, living beings or something. I don't know. You can inherit from even more stuff, right? And that you branch off from like living things and non-living things, like rocks are in a different place. So yeah, you can get as generic as you would like, and you can have a lot of shared things, and it limits the duplication, and it kind of is in theory logical. Okay, that's what we would like to do. Does that make sense? All right. So that's going to let us reuse stuff, and that is the idea of inheritance. So inheritance is when you have a class and you're basing it on another class. You're building on top of it, right? And that lets you reuse the stuff from the parent. You can think of this like tree relationships for sure, because this is an inheritance tree, more or less. It's like a family tree, right? You're inheriting things. So that lets you reuse stuff. There's a bunch of different words for these different things, like animal is being inherited from, so you can think of it as like the parent class in like a tree relationship. Some people also call it the superclass or the base class. You'll hear those all the time, and so I'm just going to say them all interchangeably just to get you used to them. So yeah, animal is the base class or the superclass or the parent class. All those words work for animal, and then cat and dog are our derived classes or our subclasses or our child classes, we can say. Does that make sense, those words? Hopefully you can see where they're coming from. Any of them work. And yeah, we say that the derived class inherits from the base class, or swap out any of the other synonyms. Yeah. So that's the goal. And also, we know that we won't get far enough with the talk as well if I just said that and I stopped, right? Because talk needs to exist in both of these, but we can't just put one talk in animal and say, I don't even know what you put there, right? Because they're both different, right? The implementation, like talk exists in both cat and dog, but the implementation is different. So there should also be like a way to override, just like mark the fact that yes, all animals can talk, but there's different ways that they talk deep down, right? So you can override the base class's behaviors with more specific things for cats and for dogs. Does that make a little bit of sense? So that's another thing. That's where you can get really, really cool stuff. That's I don't think I'll have time to show you how very, very powerful that is. So look into inheritance. Read a chapter of maybe your CSCI 40 textbook. It should be in there, in theory. That's where we're going. All right. So let's talk about, are we ready to see how we would use inheritance, how that works, what the syntax is in C++ for it? Ready? All right. Here it is. It's very small. We'll make this in C++ eventually, but we got to get there first. So let's see here. How do I want to do this? We'll get there in a second. So here is the animal class. Here's what we want. All right, what we're going to do is we're going to make an animal class. We're going to put all the common stuff, and that was the name and the age. The data, the common shared data was what goes in the animal class. Okay, shared data goes here. So just make the animal class as you would normally make it. All right, you still got a constructor that sets all the shared stuff. That still makes sense to want to do, right? Constructor, if I can spell constructor. That sets all the shared stuff, as it should. The talk method, we're just marking that there is a talk method by putting one in the animal class, which is useful to know. That means that any animal you can call talk on by putting it there. Does that make sense? Because it's getting that. It's always getting that, but you should be wanting to overwrite it in your subclasses. That's a thing. But yeah, just by putting it in the animal class, by putting talk in the animal class, that's marking that anybody who inherits from animal by default has a talk. We know that we can call talk on it. So every animal has this, and that's useful information. Every animal has this. We know that now. Including the subclasses, of course. We're going to overwrite it in our child classes. We'll overwrite it. Okay, that's good. And then all of your getters and setters, which are going to set your shared data that's part of the animal class. This also exists in animal, of course it should, because that's where the data lies, those ones at least. And then all these are getting shared, right? Gets shared with all of your subclasses. So you have the ability to set stuff still in a dog. You have a get name method. It's there. It's part of you because you've inherited from animal when you're a dog, when you're a cat. Gets shared. So like that's the setup. I still need to show you how to make the sharing happen. But does the left side of this page make enough sense? Like that's our animal class. There's the shared stuff. Just like we'll put them all there. And then I need to show you how to do the inheritance with all the subclasses. All right, there we go. So that's great. That's wonderful, and that does not look like an S. There. Okay, so that's the left side. Here is how you say, I would like to make a class, and I'd like it to inherit from somebody else. This is what you do. You say class, give its name, class dog, and then you say colon. Then you say public name of the class. Usually it's always public. I'll show you what that means. Maybe not today, but later. But public is the right way to inherit, almost always. All right? And like, here's the name of the class, and it's inheriting from animal. That's what you say. Dog, colon, public animal. Some other languages, like the default, like there is no other thing that you can do. Some people just like dog, colon, animal, is what other languages do. But ours, C++ gives us even more control. It's weird. So that's what you say. But the second you say that, dog has just imported all of this stuff. Does that make sense? That's what's happened. The second you say that, a dog is an animal. We've marked that. You can call .talk even if you didn't say anything here. Like you get the animal noise implementation. You would get it for free. You can say inside of it, get name, set age, anywhere on any dog object because you got it for free by inheriting from animal. That was the beauty of it all. Okay? It gets a little weird with the constructor. I like this because when you make a dog, you still want to give all the things that make a dog, right? You still want to give the name, the age, the college. The second you make one, that's your parameters to that dog constructor. The new things, all you need to do though, your data, you have a name and age for free by inheriting from animal, but you still need to set it right with the constructor. You still need somebody to pass along when you're making that actual dog, the name and the age. So you make those parameters still, and then you add the third thing, right? You add the new thing that's just for you. Like you add your new fields down here in the private section of dog. Like the new thing that's not in that was not part of an animal. Like you get these for free. College was the new thing, so you put that there. And then you want to set all three in your dog constructor, right? Set all three. And the way you do that, a good way to do that is to use the initializer list. You say, all right, you gave me all these things, colon. Here's how you can here's how you can set the name and age, because the name and age were a piece of the animal part that lives within the dog, right? You can call the base class's constructor. You can say, all right, call the animal's constructor, because I am part animal. Call the animal constructor with name and age because that's what it took. See that? And that will set the name and age parts for free. You can reuse that constructor and you set the college that was passed. You do the extra stuff. Does that make sense? That's that syntax. You could have also in the body here, if you wanted to wait until the body, if you don't like initializer lists, you could have also just called set name and get set age or whatever. Like those exist for you still. Okay, so that's the thing. Here is what you do to make a new talk method. You just overwrite, you give a new implementation. Like you had one, but this one's closer to the dog. Like that's the one that's going to take priority. If you make a new one, you overwrite it there. Overwrite it. The talk method. This makes me feel very nostalgic, by the way, because this was when I interviewed for the professor job here. They asked me to make a a sample lecture and give it on inheritance. And so this is part of those slides. It's funny. All right, so here's the talk method. And then we've got, like with the updated stuff. And then we've got the new stuff, right? We still need to add the new stuff that's just part of dogs only, like college. We need to add the new getters and setters because that was not inherited, right? That was not part of the old stuff. So that's all there. And I think that's most of what I wanted to say. It'll just work, more or less. I think we're good. Does that make enough sense? Are there any questions about that? Do you see the setup? Let's see here. I think I can go to code now. Maybe. Yeah, I think it would be useful to go to code now. I'm at least going to try. So here, it's going to take a second to do this all, but let's make this happen, and I'll show you it in action. Boop. I would like string names, right? So I need the string library. And so my goal is to do something like this. I would like to make cats and dogs. Like here's the dog. I want to make Alonzo object. I would like to make a dog object. Dun, dun, dun. So like I want to be able to do that. I'd like to like call methods on the dog. We'll get to that. Let's just do the implementation for now then. Let's include the animal class here. It's just going to be a lot of copying and pasting and fixing because, oh man, it does the weird space characters. All right. Let me bring in all of these then, and then we'll deal with it. We'll deal with it later. There's that one. I guess, I don't know how to do cat. I'll just copy dog. And we'll change it to cat together. Public animal. So we've got some weird characters when I copy from PowerPoint, sadly. Let me replace those really quick. Whatever that was, replace it with a normal space, please, everywhere. Excuse me, thank you. All right, so we got those there. Let's bring them all on normal lines. So there's that. Here's the data for every animal, names and ages. I'm just going to be lazy and do everything within the class. You could have done it outside. So the constructor should be setting the name to the name, the age to the age that you passed. And then we can have an empty body. The talk is good. That's our generic talk method. It's like animal noise. You at least know that every animal has a talk method now, just by virtue of putting that there. The get name is, as you would expect, it takes nothing, it's const, it returns a name. The set name takes a new name, const string new name, and it sets the name number variable to that new thing. The get age is const, and it returns the age, which is our member variable down there. And then set age takes a new age and sets our age member variable to new age, because we are good object-oriented programmers. That is the animal class. Okay, so now let's say this. Let's do dog : public animal, and just briefly, because I'll say this on the next slide, but let me try to explain in a nutshell what :public means. It's like I want dog to inherit from animal, but I want to inherit it publicly in that way. So that implies the idea that we could do something like this. If we did, I'll just like do it by analogy. If we said dog inherit privately from animal, what would happen is it would bring in everything from animal, and anything that was private stays private, and anything that was public also becomes private. Like shoves it all down. All the access modifiers get shoved down to privateness. What : public means was keep everything public, keep everything private, just like don't change anything at all. That's what that means. I'll have a slide on that, but that's the gist of it. If I did dog : private animal, all the inherited stuff from animal that was public becomes private. We want to keep the public stuff public. the private stuff private. So like, don't change anything, inherit publicly, keep everything at the same level, please. That was the highest level. Don't shove it down at all. So that was that. So here's dog. What we can do is we can call to set the animal bits of a dog and say colon, animal, name, age, do that. And then set the new thing, which was the college. And that was our our new field. All right. So that'll work there. Our new talk method works like that. It looks like that. And then our new stuff, new getters and setters, is the get college is const, and it returns whatever the college is. And then our set college takes a new college they transferred, and then you set it to that. Okay, so that's dog. And that seems to be what I wanted. Does that make sense? It all is typed out together. Everything that we want from an animal, we can call on a dog object. Like I could say right now, I could say Victor E. dot get name. That was part of the animal stuff of Victor E, but it was inherited. I could say that now. It's part of it. All right, let me finish off cat now, though. So cat is a cat, and what is its new stuff? We got new, one new fields, which is favorite food, right? We got that, and then it was name, age, favorite food. It inherits from animal, and so we did that for the animal stuff. We initialized the animal stuff for a cat, the name and the age, and then instead of college, it's favorite food. Set that to the favorite food that you passed along, and we can have an empty body again. So that's great. Overridden talk method that says meow. And then the getters and setters are for get favorite food and set favorite food. And then it's set favorite food. New favorite food. Just a lot of typing. You can imagine the implementation is not too bad, but it's just you got to do it. And so there's my new fields. Does that work? Yeah, it looks like it's happy enough. So that you see how that's in, again, it's taking all the animal stuff and we're adding the new stuff. Everything that was part of animal became part of us. So in addition to favorite food, we have names and ages. They're in us. It's just the animal part of us. All right. So I guess what's the, like, I got that dog in me, that like the dog had got that animal in him, right? That's how you say it. All right. So I can use the animal parts of Victory. Split screen. What can I do to an animal? I can ask it to talk, of course, but we know that we have an overridden version of the talking, but we can ask it to, like, tell me your name, tell me your age. You can set it to something else. Like, all those things exist for us. So let me split like this, actually. Here are some things that I can do to an animal. All those guys. Oops. So I can say, hey, Victor E, give me your name. Print it out. Apparently his full name is Victor E. Bulldog, like he has a last name. So you can say Victor E. set name. Like that's still there. That's a public thing. I've inherited. Victor E. Bulldog. All right. And then you can output his name again. That should have changed. You can say Victor E. Hey, talk. That'll hit the overridden one, the one that was closer to the definition of dog. That's great. And then we can do the same for Lonzo. Hey, Lonzo, talk. Boop, something like that. And so, yeah, let me show you that all working. I hope you kind of see the point of it all. Whee. Victor E, Bulldog, Go Dogs Go, and then meow. We understand the output is as it should be. And all this stuff, the get names and the set names, that was animal stuff, wasn't it? That was all this. It was inherited for free by the dog class. We didn't have to copy and paste it. You just put one good implementation up in the base class. Everybody can use it. It's hard to mess up at that point. Harder to mess up. Okay? And so everybody has agreed that this is a good way to do things. This is part of object-oriented programming. Yay. So, yeah, any questions about that before I make it more complicated? Because there's more we could be doing. So yeah, just a brief segue into brief intermission onto that colon public thing. So this, what that means is it controls the access of the inherited stuff. So I'm inheriting, oh goodness. I am saying colon public to inherit publicly, and that means I would like, hey, when I'm making this dog class, force everything that I'm inheriting from the animal class to be at most public. And that's the most, what's the word? That's the least restrictive one, right? So that just means like, all right, everything that was public, keep it public. Everything, there's a new one called protected. We'll have to talk about that. Everything that was protected, keep it protected. Everything that was private, keep it private. Like force everything to be at most public, but keep it the same if it was less than that. So that just means inherit everything with the same access modifier, access specifier, which is usually what you want. Keep the public things public, the private things private, etc. Okay? Usually you want to do it this way. Usually no other reason to inherit in other ways. Colon private would do the same. It would be like force all the inherited stuff to be at most private, and private is the lowest level, right? So anything that was public from animal becomes private. Anything that was protected became private. Anything that was private became private, stays private. So you marked everything private. You don't let what that means is you are not letting the user of the class use any of the inherited stuff. The user who makes the object. You, the implementer, get to use anything, of course, but you've made it all private to anyone outside. See that? Like you've just sectioned off. You mean, if you set it colon private, you would not let the user call get name or set name. That would be impossible at that point. It would be private now for the user. You get to use it, of course, but the user does not, sadly, all right? So that's the thing. Actually, you might not get to use it. I need to be specific there. I just haven't taught you the word protected yet. Just imagine that you could use it. So that's the thing, okay? So I think that's most of what I wanted to say. I have a question for you. So here is, here's two questions. Let's go to the ByClicker page. So please get into peer instruction groups. I'll start the question. Have both answers ready to go, but you can start by discussing the first, and you can enter in the first answer. But here is a inheritance hierarchy. All right, we've got some ISA relationships going on, like cats are animals, dogs are animals. A bird also is an animal. A penguin is a bird, right? My question to you is, how many derived classes are there, and how many base classes are there? Discuss.
Is it bird?
There's a philosophical question buried into this. Yeah, there's a difference between all that and normal. So let's do the first one, but have a second.
Yeah, I agree. Really have it kind of thing to do the definition. So let's go to see anything for the top is correct. Starting at 11. That's what we started. Both of these I notes for the main tree because I was mostly just confused on how to insert the tree.
All right, a couple more seconds.
Sounds like you got this. You figured it out.
All right, that is my timer. Let us take a look. So please enter in your first answer. If you haven't already, click A, B, C, or D. There's no secret option E this time. Maybe that is the answer though. How many derived classes are there in this picture? We are thinking C, and C is going to be the right answer. So the question is bird is a weird one, right? That's the question that we had to figure out. So the secret is bird is, yeah, we'll talk about them together actually, but 4 is going to be the right number there because a cat is an animal, inherits from animal, it's derived. A dog is an animal, inherits, it's derived. A bird is an animal, it is derived. See that? And then same for penguin. A penguin is a bird, it is derived. So 4 total, just not animal. Yeah. And then how many base classes? That might influence the question's answer for this one. Please enter in rapid fire. I'll give you 15 seconds. How many base classes were there then? What does it mean to be a base class? See if your mental model is the right one. All right, we're thinking B, and that is going to be the right answer. There's 2. There's 2 base classes. We know that animal is for sure a base class. It's being inherited from. That's what it means to be a base class, right? That means bird is also a base class. It's being inherited from. See that?
Oh.
From the perspective of penguin, bird is a base class. See that? So yeah, I guess the trick is like to count derived classes, you just count all the arrows.
Oh.
Count all the arrows for a derived class. Like cat is deriving from animal, dog is deriving, bird is deriving, penguin is deriving. And then for base classes, you count who are targets of arrows. Count the targets of the arrows. Boop. So animal, bird. See it? 2. That's the trick, I guess. Any questions about this? Does it make sense? It's just conceptual, technical question there. Here is a philosophical question. I'd like you guys to discuss with each other, I guess. Or maybe, I don't know. I think we have time for it, maybe. I'll give you a couple minutes to discuss. It is for fun. There is no right answer. But let's say we've got a square class and a rectangle class. My question is a square a rectangle, or is a rectangle a special case of square? You could go either way. Square class as the base and rectangle derives from it. Boop. Or you could start with a rectangle class, and you could have square derived from that. What's the right way? Think about it in terms of like shared data, like who's going to have what, the base class that you're going to want. Like you're becoming more specialized technically, right? When you're deriving. Take like a couple minutes to discuss, and then we can see what we're thinking. You don't have to write it down anywhere. It's an interesting question. I think it's philosophical. There is not a right answer.
Yeah, it's mostly just Or it could. If it's personal, all the ones totals.
It would make sense to add so that. So like, we were doing.
90% squares. But it just feels like, yeah, you should look at one that's in here because it's traditional. Like you don't have to, but like it would just help you organize it better in my mind.
All right, that is.
Yeah. All squares are actually, it's not all squares. I get it.
That was my timer. There again, there is no right answer. I hope that maybe you guys convinced each other. That was fun. But honestly, it could go either way because if you think about it, it works. Like the ideals of inheritance work in either direction. Like square is more basic; it only has a width, right? It's like the same in both directions. A rectangle is an addition of a member variable, isn't it? You got a width and a height now. It's not the same. So like that would work. But also a rectangle is more generic, and a square is like a square is a special case of a rectangle at the same time, right? It's a more specialized version of a rectangle if you think about it in that way. It's still it's where your getter and your, like if you were to set the width of a square object using the rectangle's inherited set width or something, it would also lock the height to be the same, wouldn't it? You'd have to override that in some way. Like there's a way to do it either way. There's a way to do it either way. It's a philosophical question. It comes down to your mood, I guess. So yeah, that's fun to think about. I hope you agree. There's one last topic that I want to get to before we end today. I want to talk about static and dynamic dispatch, which is a complicated topic that is new and specific to inheritance. It's very, very, very powerful, and it is one of the good reasons to use inheritance, but it's going to take some explaining, all right? So I kind of hinted at it when I said the talk method, and putting it in the animal class was a good idea, all right? So one nice thing, like, let me just read it. When you do inheritance, it's very cool that you can do the following, and I haven't shown you that you could do this yet, but it's something you can do. It's very nice. You are able to treat derived classes like the base class and use the base class pieces only. All right. What I mean by that, it's a weird thing to want. What I mean is when you have an animal, right, you're never just going to make an animal object. That would be silly, right? You want to make a cat object or a dog object. You're never going to call talk on an animal, right? So you could imagine that it was silly for me to put this here. All right. It was a really good idea for me to put this here, though. I'm going to try. It has to do with static and dynamic dispatch. Because I put it here, this guarantees that any kind of animal has a talk method. You are going to want to override it, of course, but this guarantees that if I have anything, I want to treat it like an animal, I can always call talk on it. That's what I want. All right. And that's the difference between static and dynamic dispatch. Well, let me show this to you, all right? You can treat, this is how we get there, though. You can treat a bunch of derived classes like their base class and just use the base class pieces because you know that they have those in common. You know that those exist, all right? So, for example, we know that animal has a bunch of pieces that are shared to cat and to dog. So animal has, oh, sorry, I need more room. Animal, if I can spell. Animal has get name, I can call that. Animal has talk, I can call that. I know that any animal has those things, right? And then cat and dog inherited from animal. They inherited from animal, and I gave them new talk methods, all right? I gave them new talk methods, dot talk. Overridden. New dot talk. Overridden. here's something you can do and something you will want to do. It's not going to work right now. We need dynamic dispatch, but this is the motivation. This is something you will want to do. Let me include vector. This is going to get really weird, but it's very useful. Okay. Dun, dun, dun. You can't do this with the actual objects because it cuts things off. You can make a vector with both Lonzo and Victor E inside of it right now. Do you understand why you might want to do that? That makes sense to want to be able to do that. I would like to make a vector with Lonzo and Victor E together in that same vector. I can't make a vector of cats or a vector of dogs, though. Does that make sense? I can make a vector of animals. See that? That's what I can treat them like the animals that they really are secretly. But I can't say it like this. I can't say vector animal, sadly, because that just cuts off pieces of the actual type. I can't say vector animal v, but I can say vector of either animal reference or animal star, because that keeps the same stuff in there. Like I'm referring now to an object that's already there. So like that's fine. If I said animal, it like makes copies and cuts things off. But I can make a vector of animal stars, for example, and have them point to Lonzo and Victor E and put that in the vector. So I can do this. Equals and address of Victor E. Address of Lonzo. It has to be either a pointer or a reference for weird reasons, but I can do this. I can treat these guys like the animals that they are secretly, right? That's where they came from. I can make a vector of animal pointers and put pointers to derived classes inside. That's great. I can keep them all together like that. That's really nice. This is possible because every cat / dog / bird or whatever is an animal. You can treat it like one. The second you do that, though, you can only use the animal pieces of that type. That's why you wanted talk and animal. Does that make sense? That's why we put that there. You've marked that it exists for everybody. If they don't override it, they're going to want to override it, but if they don't, at least you get the generic one, right? You can do that now, and now you can iterate. Now you can iterate through this vector and be like, hey, for every animal star A and V, like, I just want to use them. For every constant animal star A and V, see out, hey, ask A to get its name. And then print out its age as well, or like tell it to talk or something. Say like A arrow talk. Let me not do that part yet for a weird reason. But I can go through everything and use something that came from animal. Ampersand or exclamation point G++, yay. I forgot a new line. That's beside the point. But here we've got, let me just do a new line for now. Not work, but it's working. It's printing Victor E. Bulldog, and Alonzo is his full name, but I never say that. Does that make sense? You're able to treat your derived classes like the base class, because they are. They have that inside of them. They all do. And you can use all the stuff that an animal had. You're guaranteed that you get all this, right? You have that ability, because every dog was an animal. Every cat was an animal. You can treat them like the animals that they are, and use the animal stuff. Right? Put them as a vector of animal stars, use the animal parts of them. Isn't that wonderful? That's great. That is a very powerful thing that inheritance gives you. You have a bunch of different things. They all work together in that similar way. Use the similar parts all together. Bring them all together in a vector. That's okay. This is where it gets weird. Go in space. Morally, this should print Victor E. Bulldog, go dogs go, Alonzo, meow. Yes? That's what we want. That is not the default. We get animal noise. Unfortunately. All right? There's a way to get what we want. All right? The solution is to use the idea of virtual or dynamic dispatch. All right? You're forced to use pointers and references for this reason as well. Making a vector of just animals cuts off the specific pieces that marked that it was a cat or marked that it was a dog. All right, so I'm going to use some new keywords called virtual and override to fix this problem. All right, so think of the idea of virtual as When I say virtual, I'm going to mark cat and dog and animal as virtual things. Virtual just means prefer to use the most specific one. Prefer to use the derived overridden thing. Virtual. It marks it as dynamic dispatch. Virtual is please use these instead. Please use these instead. Or please use the most specific thing. Please use the derived classes stuff. Because if you think about it, static dispatch is what we got for free when we just said like animals. Every time I said like get name, it went up to the animal part of the implementation and ran that. And that's what we wanted for get name, right? But it's not what we wanted for talk. Every time I said talk here, by default, it's like, all right, this was an animal pointer. I will go up to the animal implementation of talk and run that. That is not what we wanted for talk, right? That one, we wanted it to, on the fly, notice that it was a cat and call the cat's version. Or on the fly, as we were calling the method, notice that it was, oh, this was part of a dog object. Call that version, okay? That's what we wanted. And so here's how you get that to happen. We mark talk as a virtual method. All right, you do that in the base class, and then you say override in all of the subclasses where you've overridden it. So a virtual method, here's the actual definition. It's one where you want to prefer the subclass's implementation, no matter what type you're using to store the object. All right, if it was an animal star, but we were calling the where are we? If it was an animal star and we were calling .talk on a dog, though, on a dog pointer arrow talk, we should have gotten the dog implementation of talk. Like it should have noticed that, oh, this was an overridden thing. Go use that one. Go use the most specific one, not just the animal's version of it. That's called dynamic dispatch, virtual dispatch. So, yeah, like that's how that works. So if you have a vector of animal stars, star v at 0 is secretly a dog. That's the way we did it. Star v at 0 was a dog. It should be able to call the dog's talk method. Same with the cat version. All right. So virtual methods introduce what's called dynamic dispatch, and that just means like on the fly dynamic. As the program's running, it notices that, oh, this method, I'm calling it on an animal, but really this animal is more specific. I want to use the more specific version of that implementation. That's what it's doing. Figuring out which one to call on the fly, figure out which class it was a part of. All right. So let's do that, and then I'll talk about the last bullet. So that will fix all this. So what you do is if you want it to always prefer the overridden implementations in the base classes, you say virtual void. You mark this as a virtual method if I could spell virtual. Virtual. There we go. Virtual void talk. All right, that's the first step. That marks, you just do that at the lowest level, at the highest level, sorry. The base class, the first time this appears anywhere. This is being inherited now. And so it's always going to be virtual the second you mark the base as virtual. So every talk method now ever is a virtual method, we say. And that means it is going to prefer the overridden stuff if you override. And so honestly, you could keep everything else the same. You could keep these talks the same, just like the fact that you gave it again means that it's overridden. But it's good practice to mark that it's being overridden here. Override is a keyword that's specific to virtual methods. So it's saying I'm marking the fact that I'm just acknowledging the fact that this was a virtual method and I'm overriding it now. You get a compiler error if you forgot to say virtual, I think. So that's why you say that there. So we're overriding. Override the talk method. C++ already knows, because we've inherited it from animal and the animal version was marked as virtual. C++ already knows this is virtual, so you don't say it twice. You just start saying override. And it is good practice to include the override part. Not necessary, though. So, because it'll give you a compiler error. It's like, oh, that wasn't virtual. That's what we want, though. The same for cat. We want to override the talk method from the base class, just to spell that out to the compiler and us who are reading the code later. We say override here. And that does it. That makes all the difference. The second we mark this as virtual, it's going to prefer the subclasses, the base class, or sorry, subclasses, child classes implementation, not the base class. We get exactly what we wanted by saying that. It will prefer whatever it really was. Prefer the overridden stuff. Mark that we care about that. We don't want just to jump up to the animal stuff. If we treat something like an animal, don't just jump up to the animal implementation of this kind of method. It's a virtual method. Dynamically figure out, was it a cat or was it a dog? Call the right talk for that object. Okay? That's what virtual means. It gives us what's called dynamic dispatch. It figures it out on the fly which one to use. But even though to the compiler, this was just a pointer to an animal object. No, it figured out that this was a specific kind of derived thing from an animal object for this method. So that is useful. Implementing how this works. One day you might take a compilers class and you'll have to learn how that works. I will maybe draw a picture next time. There's a very interesting thing. Like it takes some extra space of every object to be able to do this, and so you are trading some space to do this, but it's a very important thing to want to do. So I hope it makes at least a little bit of sense, and that is inheritance in a nutshell. Are there any questions about this example before I say one last thing? It's really cool, I think. It's very powerful. People like it. This is just a word of warning. We're not using it for this one, but like imagine you had you're inheriting from vector, like your vector class or something. You were doing weird big 3 stuff. You always want a virtual destructor if you ever override a destructor. If you ever have a destructor as part of a chain inheritance hierarchy, you always want a virtual destructor because you know that in your derived class, you're probably making new stuff on the heap, right? You don't want to just go to the base class's destructor and have it only destruct the stuff that it knew about. Yes? You always want a virtual destructor the second you have a destructor anywhere and inheritance. That's the moral of that story. So that will one day perhaps become apparent to you, but I'm warning you now. That's a very important thing that will cause memory leaks if you don't do that. But I'm not going to give you an example. It's very complicated. All right. So yeah, I think that's what I wanted to say. Are there any questions about any of that? That's where I want to stop, I think, for the day. All right. So yeah, inheritance is fun. There's more to it. That was the bulk of it, though. That was some important stuff, and we will get to more later next time. And it will eventually be part of your final lab in the class, which is exciting. And I guess we'll give it to you in a couple weeks. We got to get there. So yeah, I think that's what I wanted to say, and I think that's what I wanted to stop on. There's no new assignments this week. There's only one more lab, but I'll give it to you. I got to give it to you week 16 when like the Tuesday before Thanksgiving, because we need all that knowledge from that lecture.